The next talk is by Torbjörn Einarsson, and he's going to talk about a reference dash live video source. So please join me in welcoming Torbjörn.
Okay. Thank you. It's really nice to be here. I'll speak about video and Dash and what I've been doing with Python in this context. So I'll start with saying something about me. I've been working with video for about 20 years, and not about video content, about the video bits and the formats and standards and everything like that, and transport and streaming service and things like that. So 16 years at Ericsson Research, and now the last 4 years at Mobile TV. And I found Python on my parental leave 13 years ago. And I've been using that a lot since then for prototyping, building testing tools, and then for a lot of video tasks like, oh, actually this is cut down here, so that's bad. There should be some more lines. How do I fix this? The projector is not a 4x3 projector in a good way. So let's see if I can do this somehow. How will you do this? That's a problem. I should have. Anyway, it will take some time. So what I've been doing is to work with video transport, video formats, generating synthetic video, do analysis, and a lot of things. So, first of all, video is exploding on the internet. I think something like 90% of video is video nowadays. And compared to traditional video, like TV and also your cable TV now, or IPTV actually, and also the introductory mobile TV, now everything is over HTTP. There's no RTSP or RTP or UDP to your mobile devices anymore. And this also is being reflected in HTML5, which has finally got a video element. Before HTML5, you had this type of objects and a lot of strange stuff. And the first phase of HTML5, you could add a source and then give a URL to a video file, an MP4 file or something like that. But then in the newest API, with the media source extensions, you can actually feed small chunks of video into your browser player. So this is what is being used now, the media source extension. And since this is doing chunks, segmented video, you can start doing things like adaptive video, where you actually are changing the bitrate depending on the download speed. You can also do live, because you can take chunks, 2 seconds and 2 seconds and 2 seconds of video, which you couldn't do before. What you then need to do on the client side in the browser is that you need to write a player in JavaScript. So you will skip all the plugins like Silverlight, Flash is still there, but it will vanish. And you will instead sort of have your own JavaScript player, which is fetching segments via XML HTTP request and then feeding them into a source buffer. You could do this in various ways, but the standard way of doing this now is to use something called Dash, which is a new standard from MPEG. So that describes how the segment looks like, and how the manifest looks like, and how you do the whole thing. Another thing which is coming up with HTML5 is EME, which stands for Encrypted Media Extensions, which means that you can also do DRM in the browsers. I will not speak more about EME, but it is an important part, because that allows you to have the premium content to the browsers. So now I'm coming to Dash, and that stands for Dynamic Adaptive Streaming over HTTP. It's a standard from MPEG, although it started in 3GPP. And it borrows from other HTTP streaming schemes like HLS, which Apple invented, smooth streaming from Microsoft, and so on. So it has taken some parts from one and some parts from another. It has added more use cases and flexibility. And it's starting now to get widely used. So Netflix is using it, so in some browsers. Chrome, in the latest version of Chrome, from Chrome version 42, you cannot use the Silverlight plugin anymore without going into the settings. So there, Netflix is using the media source extensions, and Dash is also used in Internet Explorer 11 on Windows 8.1, Safari 8 on OS 10 Yosemite. And here's actually with different DRM schemes as well. It's Widevine on Chrome, it's Play Ready on Safari, and FairPlay on, well, it's Play Ready on Internet Explorer and FairPlay on Safari. Google is using Dash now, YouTube, that's the default now. If you're going to the Chrome browser, it's not Flash video anymore, but HTML5 video using Dash. And Microsoft is supporting this now also in Windows 8 and getting there. In Dash, there are two components. One is a manifest, which is describing the session. That's an XML file. And then this the actual media, which is the segments. Dash is a standard. And it was made together with a lot of companies, some 20 companies or something like that. And all these companies wanted their own sort of niceties and their own patterns into the standard. So it's a huge thing. So therefore we need interoperability. And for that, there is a new organization called Dash Industry Forum. And we are about 60 companies there now, or something like that, including Google and Microsoft, and Akamai, Adobe, and a lot of other companies. And this Industry Forum is producing guidelines. A JavaScript client called Dash.js, which is a reference client, which is on GitHub as open source. And also test vectors, which is sort of special content which is prepared for video on demand and live. It should have live down here. But live testing is quite hard. For live video, you need a feed, some source, and you need an encoder, which is running there all the time, and these are typically expensive to have. And it also has some timing issues. So Dash IF is lacking a bit of testing for live video. So therefore, they have asked me to make my live simulator the part of their test suite. It was otherwise developed in-house for our own testing. And since it is a simulator, it doesn't need any feed or encoder, and we can do a lot of different test cases at the same time, actually. The MPD is the manifest, and it's an XML description, which looks something like this, a bit simplified. So it contains the links to the media, and this actually what it does is it tells them a session is starting for live, how long are the segments, this is dynamic meaning live. It says that there is some audio in here, some video. It says says the bit rate or bandwidth and a lot of things like that. So it has and you can have multiple bit rates in this specific MPD. There's only one audio and one video, but you could have, of course, other things in there. Multiple videos, so that you can adapt to bit rate. You can have multiple audio languages. You can do a lot of different things. You can also have multiple periods, so that you have one program and then another program coming later on and things like that. So there is a really big flexibility, and for testing all this, we need a lot of different test vectors. The next thing is the media segment, which is an MP4 or ISO file. It's also standardized by MPEG. It can contain different type of media, like video in H.264 or HEVC format, audio in AAC format, and things like that. It's built as a hierarchy of boxes. So it's actually, and each box has a size field at 4 bytes, a type which is 4 characters, and then the actual binary content. And then you can have a hierarchy like this. Is a first box as S-type box. Then there's a move box. Inside that move box there is an MFHD box and a trough box, and inside that trough box there are other boxes and so on. So this is the structure. But for each of these boxes, there's first a size field, and then there's this 4-letter name of a box. So it's relatively easy to parse. And what we need to do to make a live stream is that we need to make sure that the timing or that the sequence number of each segment is increasing all the time, and that the timing is correct. So the approach I've taken here in this simulator is that I'm using on-the-fly generation of everything. I'm using mod Python with Apache, and I start with a dash VOD source, which is 1 hour long. And then I have a configuration file, which actually I know something about the sequence because I scanned through it. I check how many segments there are, how long they are, and a lot of things like that. And then I take in the URL, I can specify the different options, like if I want multiple periods, if I want it to start at a certain time, and so on. And then I make this content available depending on the wall clock. So right now, certain content is available. 10 seconds later, it's something else, and so on. And I make sure that everything is sort of nicely configured. And from this 1 hour sequence, I get an infinite long video sequence. So the MPD goes from VOD to live by doing some tricks to it. I can then also do some time-limited services and periods, and for this I use the element tree package in Python to sort of filter and manipulate the XML. For the segments, I'm making them into an infinite series, and I'm using the struct package there for and packing and unpacking binary data. So this is some test cases which I can do. First, an infinite series, a 24/7 series, 24 hours a day, 7 days a week. And then I can change some parameters like what is the time shift buffer depth and things like that. They can also be time-limited services. This is 1 hour service, and then it's stopping, and then there's another service coming back later on, and so on. I can have multiple periods. I can signal that there are some ads coming, so that on the client side we can do ad insertion in the live stream and get personal ads. I can also add, it's not visible here, UTC timing. So let's move it over here. Whoop. Which is a way of synchronizing the client clock and the server clock by sending extra headers. Whoop. So now I'm trying to do a demo which looks something like this. So before showing the demo, I will tell you what you will see. This is down here to the left is the VOD segment, which is sort of a 1 hour long sequence. as I start it will start from 0 and then go up, go upwards, because video on demand always starts from the start. Then over here is a clock showing the minutes and seconds of the current hour. And up here to the left is one of my live sources, which is the VOD sequence, but now being made into a live source. And this is now sent out synchronized with the war clock, but because of the buffering in the system and things like that, it will be a bit behind the real time. So in this case, you can see that it's 11 seconds behind. And then one can have different segment durations, so downloading bigger or smaller segments. And this is 2 seconds, and then there's 11 seconds behind. This is 6 seconds, and you can see that it's about 22 seconds behind. So that is a parameter in general that you can use. And now let's see if we can get this running here. Here we first have a player. If you want to see, this is for one sequence just. I mean, this is the reference player, by the way. See if you have any network connection. You can also turn on the audio here. And there should be a beep every 1 second, and every 1 minute there is a different beep. But so this is live. Very interesting test sequence. But I could put in any other video actually. So let's stop this guy, and then we take this one and instead look at this multi-video thing. So this is VOD down to the left, starting from 0. Then we have these 2-second segments up here, which is a very long time here because it started in 1970, so it has been running for a very long time. And then we have 6 seconds over here. So maybe you will not use this sequence in the future, but at least you will be doing video over video with HTML5. I'm pretty sure. Good. Yeah, it's around forever. I will not prove that it will wrap around properly, but it will. While this guy down here will stop after 1 hour, actually. Yep. Good. Let's get back to the... I need to find my pointer. Yeah, it's over here. So, just I'll tell you a little bit about the environment I am running. This is now running on an Apache 2 server in the Amazon cloud. So I'm using mod Python to start up the Python thing, but not any really fancy things about mod Python. It's a stateless server. Everything is in the URL, like all the different configurations and things like that. It's hosted by -if at this address vm2.-if.org. And the source code is actually, now I've transferred the copyright to -if, and it's an open source project since last week. So you can go there and find the source code if you want to use it, or if you want to contribute to the project. For players, we are having these browser players. And we start to have, and now, well, they actually work on other other browsers as well, but Chrome is one I'm using most. Dash.js is the reference player from -if. Shaka Player is another GitHub project being developed by Google. So there are 2 open source players for the browser. They will also work on the Chromecast, the dongle, and in Chrome OS and things like that. There's also an Android open source called Exoplayer that you can use. It's also on GitHub. Before making this open source, I thought maybe I should go Python 3. So I spent some time on looking into converting the code from Python 2 to Python 3. it was a bit tricky because this file format thing, it's sort of binary format mixed with some strings of boxes and things like that. So things like this, a binary size and then a small string and then some binary data again. So yeah, it wasn't automatically converted by the 2 to 3 program. And also, of course, I had some problems with integer divisions. But it took about half a day and then it worked. But when I wanted to deploy it on my Amazon virtual machine, and I found out that mod Python can only run Python 2 or Python 3, not both at the same time. So since we're having mixture of different modules, it didn't work out properly. And also looked at mod WSGI, and for Apache 2.2 on my VM, it didn't support Python 3 either. So for the moment, the code stays Python 2, but I'll change it one day. Yeah, that actually finishes up my talk. So thank you very much. And any questions?
Yes. Well, I have actually thanks. I have actually quite a lot of questions.
Yeah. Okay.
First of all, why not generate the source with, say, FFmpeg? Then why not involve, for example, WoW's streaming server into this? Well, that's the most important questions, actually.
Yeah, I mean, actually, the code itself, the VOD sequence is done with FFmpeg.
Mm-hmm.
So the actual encoding is H.264 and AOC. Once a streaming server, sure, yes, but how do you convert it to a perfectly synchronized thing where you can change the MPD depending on the URL and things like that? I mean, all the test cases that I want to do, I cannot do with a streaming server.
Okay.
But so of course I can take this VOD sequence and put it on the WhatsApp meetings sort of streaming server, and it can serve it. I'm not sure if I can get a perfectly live stream which is synchronized with the wall clock from the WhatsApp streaming server. I mean, that's a special case which I'm doing. So WhatsApp is supporting live, and it is supporting VOD. I'm not sure about the loop things. I don't think it does it, at least not in the way I know. No. But sure, it's good. These are good tools. So.
Yeah, thanks.
Can you tell me a bit more how the DRM thing works? Is it like the segments are encrypted with the key that gets sent around somewhere?
Yes, for the DRM, there's actually some light in the tunnel, at least in the sense that with Dash and MPEG, there's a new standard called Common Encryption Format. So that describes how you should encrypt the segments. So basically, the part of media is encrypted, and there is a key ID in the segments telling the IDs of the keys. And then at the start of the segment, you can tell what DRM systems you have with a unique ID. And then you can actually have multiple DRMs with the same encryption. So that's where we are heading now, is sort of multi-DRM encoding. So basically what the player will see then is that we see, yeah, okay, this is Widevine. It has a certain the DRM ID, and then it will connect to the Widevine license server, and then get encrypted keys back, which it can't. But that's following this encrypted media extension standard for how to communicate with the browser. So this dash.js reference client can use both PlayReady and Widevine. Other questions?
Any more questions? No? Thank you, Torbjörn.
Yeah.